Good morning, all of you. Today in this class, we are going to discuss about the numericals on Nernst equation. Numericals on Nernst equation. Before going to the numericals, first we will see the formula. The formula of solving the numericals. First one is for single electrode potential. Single electrode potential. In the numerical, if he is asking calculate the electrode potential for the half cell or for the single electrode potential, etc. So in such cases, we have to use the following formula. First one is E of m plus n by m is equal to E naught of cell minus 0.0591 by n log of 1 by m to the power n plus or plus n. Here I am writing star. You will see later on. If he is asking calculate the electrode potential for the given half cell and he will give the reaction, in such cases you have to solve that one by using this formula for half cell. Electrode potential for the half cell, you have to use this formula. M is the metal. Any metal he will give, zinc, copper, silver, whatever may be the metal. If he is asking electrode potential for the half cell, you should have to use this Nernst equation, right? That is E of the given metal reduction potential. Reduction potential of the given metal is equal to E naught of, that is standard reduction potential for the same metal. Standard reduction potential for the same metal minus 0.0591 by n. N means what? Number of electrons involved in the reaction. By observing the reaction, by seeing the reaction, we will see what is the value of m. Here only it is given. Next, log of 1 by m to the power n plus star. Here, this star means what? What is the coefficient of this metal ion in the given reaction? For example, this one is the given reaction, m plus n, 2 is there, plus n electrons, 2 n electrons gives rise to m. Here, coefficient of this metal ion is 2. Now, this star will be 2. That is the coefficient of the metal ion in the given chemical reaction. That will be the star. Next, second one. For cell potential or E cell, or it is also called EMF, electromotive force. Cell potential, E cell or EMF. He is asking calculate cell potential of the given reaction or E cell of the given reaction or EMF of the given reaction, etc. In such cases, you have to use the following formula, that is E cell is equal to E naught of cell minus 0.0591 by n log of the metal which is undergoing into oxidation. The metal ion which is undergoing into oxidation, that only you have to write. The concentration of that metal only you have to write here. Here also I am writing star means what? The coefficient of that metal in the reaction. Maybe 1, 2, 3, we will see. Next one, divided by concentration of the metal which undergoes into reduction. Here you have to write the concentration of the metal ion which is undergoing into the reduction. Here also you will have to write the coefficient of that metal ion in the given chemical reaction. He will give compulsory the chemical reaction. Next, you may write here product by reactant also. Product by reactant also. Here, this one is the formula which is used when he is asking calculate the cell potential or E cell or EMF of the following chemical reaction. Then you should have to use this formula. Next, third one. If he is asking equilibrium constant by giving E naught of cell, or he is asking E naught of cell by giving equilibrium constant, then only you have to use this formula. What is the formula? Is E naught of cell is equal to 0.0591 by n log Kc. Kc means equilibrium constant. N means what? Number of electrons involved in the reaction. Here, sometimes he will give Kc value and N value, then easily we can calculate the E naught of cell value. Or sometimes he will give chemical reaction. By that we can calculate the number of electrons, and he will give E naught cell value. Right? By using these two data, we can easily calculate the equilibrium constant. Equilibrium constant. In some problems, what happens? He won't give E naught cell value. Here also E naught cell value is there. Here also E naught cell is there. Correct? He won't give the E naught cell value directly. In such cases, use the following formulas. If E naught values are not given directly, then you should have to use the following formulas. The formula is E naught of cell is equal to E naught of cathode minus E naught of anode. Or it can also be written as E naught of reduction minus E naught of oxidation. Clear? Here, E naught of cell value, sometimes he won't give directly in the problem. In such cases, you should have to calculate the E naught of cell value by using these two values. Right? He will give E naught of the cathode value and E naught of the anode value, or E naught of the metal ion which is undergoing into reduction minus E naught of the metal ion which is undergoing into oxidation. By using these two data, right, you can calculate the E naught cell value. Next, simple hint I will give for calculating E naught cell value. Now, you don't know sometimes what happens, which element is undergoing into, or which metal is undergoing into oxidation, which metal is undergoing into reduction. You don't know, correct? For that one, hint is E naught of cell is equal to E naught of higher value minus lower value. Higher value minus lower. Set E naught of cell is equal to, the formula is E naught of higher value minus E naught of lower value. Higher value undergoes into reduction only. The elemental ion which is having higher E naught value, standard reduction potential value, it undergoes into reduction only. Right? If the metal having lower SRP value, standard reduction potential value, it undergoes into oxidation only. That we have discussed in electrochemical series. Same. That is E naught cell is equal to E naught of higher value minus E naught of lower value. These formulas are very helpful for solving the numericals on Nernst equation. Remember, one numerical is fixed for your theory examination for 3 marks or sometimes for 4 marks. It is very, very important. One fixed question is there on Nernst equation, numericals on Nernst equation. One problem is there in your theory examination for 3 marks or 4 marks. Later, those can be solved very easily by using these formulas. Clear? Next, here log is there. In all formula, log is there. Right? For that one, I am giving logarithm formula, few logarithm formula. Right? If log m by n is there, what is the formula for log m by n? Log m minus log n. Log m by n is equal to log m minus log m. Next, second one. Log m to the power n. M to the power n. What is the formula here? Log n log m. The formula is n log n. Next, last one. Log, if m into n is there, then what is the formula? Log m plus log n. These are the few formulas which are very useful for solving the numericals on the Nernst equation. Right? Log m by n is equal to log m minus log n. Log m to the power n is equal to n log m. Last one is log m into n is equal to log m plus log. Now, already you know how to see the log, how to see the log in a log book, logarithm book. Clear? One example, we will check here how to check the log value in logarithm book. For example, I am taking here. It is very important for 3 marks. That's why only I am seeing these basic formula and the basic things. Right? Now, if value is log of 84.38 is how much? Question is there. Log of 84.38 is equal to how much? Then how to check the log value is, now what is the formula for calculating the log value is x minus 1, here it is decimal, let us find the log value in table. Log value in table. Now what is meant by x? X is the number of digits before decimal. Here I am saying how to see the log values in the logarithm table or logarithm book. Now I am taking one example. Log of 84.38 is equal to how much? For that one we are having formula for seeing the log of any value, that is x minus 1. Here decimal is there. Log value in the table. That value I have to write here. Log value in the table. Now here x means what? Number of digits before decimal. Here digit is here, right? Decimal is here, right? How many digits before the decimal? 1, 2. Before the decimal, there are 2 digits are there. One is 4, another one is 8. Totally 2 digits are there. Therefore, x value is 2. X value is 2. It will be 2 minus 1. Decimal means how much it is? 1 point. 1 point. If it is 1 is there, right? Here before decimal, how many digits are there? 1, 2, 3. Means x value is 3. 3 minus 1 means it will be 2 points. Similarly, for here 84 point, here it will be 1 point because x is 2. Here before decimal 2 digits are there. Therefore it will be 1 point. 1 point. Here 2 minus 1 means 1 point. Here you have to write the log value. Right? How to see the log value? Here 84 is the first. Wherever may be the decimal point. Correct? You should have to take first two digits. Right? Here in log book. For example, this one is the log book. Just imagine this one is the log book. Here values are given 10, 11, 12, 13, 14, 15. Somewhere else, right? Here 84. Right? First two digits. You have to search here. Here it is 84. Correct? Now next third digit. Here 3 is there. Third digit is 3. Then only you have to search here. It will be here 1, 2, 3, 4, 0, 1, 2, 3. Here it is 3. Exactly. Now here it is 84. First two digits 84. Here you should have to search. Next 3 is the next. Here is this 3. This value you should have to mark. This value. Next last digit is 8 is there. 8 here again values are right here. 1, 2, 3, 4, 5, 6, 8 is there. Right? That is called mean difference. Here you will have to search in 84. Right? And here 8 is there. Here you will get some value. That value is added in this value. Maybe 1, 2, 3. That value is added in this value. That will become the log value. That value you have to write here. Clear? First two digits you should have to search here. First two digits, whatever may be, 84, 8.4, whatever may be, you should have to search here. Here it is. Next digit, that is 3, you should have to search here. Then you will get some value here. After that, next digit is 8, that you should have to search here, and that difference, mean difference, you should have to add in this value and write that value here. It will be 1 point something. That is the value of the log. Now, we will see the problems, numericals on the station. First numerical is calculate the E cell value. First one is calculate the E cell value of the cell in which the following reaction is taking place. Following reaction is taking place. The reaction is here. Mg plus 2Ag plus 2 raised to Mg plus 2 plus 2Ag. Here below that it is giving concentration, that is 0.001 m. It is the concentration of Ag ions in the reaction. Next here we will give the concentration, that is 0.130 m. This one is the concentration of Mg plus ions in the reaction. Now given, and already he is giving that value of E naught cell is equal to 3.17 volt. Already he is giving this value. Now we will try to solve this one. Right? What he is asking, calculate E cell. Calculate E cell value of the cell. Cell is the complete cell potential he is asking. Of the cell in which the following reaction is taking place. This reaction is taking place. Right? Two metals are there. One is magnesium, another one is silver. Right? Now, here silver ion concentration is given. How much it is? 0.0001 m. Right? Now, concentration of magnesium ion also it is given. How much it is? 0.130 m. Right? Again, that he is giving that P naught cell value is how much? 3.17 volt. 3.17 volt. Now we will try to solve this one. Solution. First, write down the given data. Given. What are the given things we should have to write first? Now, what are the given data? He given concentration of Ag, correct? Concentration of Ag plus ion. How much it is? This is concentration of O3 Ag plus ion. How much it is? 0.3001 m. And he is giving concentration of Mg plus ion. Mg plus. How much it is? 0.130 m. Here concentration of Ag plus ion is given. Here concentration of Mg plus 2 ion is given. Next, E naught cell value is also given. And E naught cell value is equal to how much it is? 3.17 volt. And he is asking E cell is equal to how much? This one is the question. Which formula you have to use? Second one. Already you know that is the formula. In that second one you have to use. What is the formula? E cell is equal to E naught of cell minus 0.0591 by n log of the metal which is undergoing into oxidation. That concentration we have to write here. Star means the coefficient of that metal in the chemical reaction divided by concentration of the reduction. The metal which is undergoing into the reduction. Here power you should have to write that coefficient. Right? Coefficient. Clear? This one is the formula. Now we will see. We know that E naught of cell value, right? It is given already. It is given. Next, n number of electrons. By seeing the reaction, we can calculate easily n value. Right? Here oxidation. Which metal is undergoing into oxidation? Here just here Mg to the power is 0. Right? Here Mg oxidation number is plus 2. 0 to plus 2 means oxidation number is increasing. Oxidation number is increasing. Or loss of electron. Therefore, Mg is undergoing into oxidation. Mg is undergoing into oxidation. Here Ag plus 1 is there. Oxidation number in the reactant is plus 1. Here Ag there is nothing means 0. Oxidation number is 0. Here oxidation number is plus 1. Here oxidation number is 0. That is oxidation number is decreasing. Therefore, Ag is undergoing into reduction. Means Mg is undergoing into oxidation. Ag is undergoing into reduction. In this way, you can calculate. Or I will give very simple thing, right? Just product by reactant. Concentration of the metal ion in the product, that is here 0.130. Here you have to write 0.130. Right? Divided by concentration of the metal ion in the reactant, that is 0.0001 m. That is here 0.0001 m. You should have to write coefficient also. Coefficient of Mg is 1. Therefore, here 1. The coefficient of this Ag is how much? 2. You have to write 2. And how to calculate number of electrons? Now just observe the reaction. Once again, I am writing here. Mg is converted into Mg plus 2. Separate everything. And 2Ag plus is converted into Ag. Correct? Select any one. Here Mg is converted into Mg plus 2. Here 2Ag plus is converted into 2Ag. Right? Now take any one. Mg to Mg plus 2 or Ag plus 2 to Ag. 2Ag. Clear? Now just check. Here, what is oxidation number? Nothing means 0. Nothing means here charge is 0. Right? 0 is there. Here how much it is? Plus 2. 0 plus 2. What is the difference? 2. Therefore, 2 electrons are transferred. 2 electrons are transferred. Right? Already we got n value. What is the n value? N value is 2. Right? Here 0 to plus 2 means 2 electrons are lost. Therefore, number of electrons involved in the reaction are 2. Right? Either you take this one or you can select this reaction. Here plus 1 is that, here 0 is. What is the difference? 1 means 1 electron. No. Here 2 Ag plus are there. 1 Ag plus is giving 1 electron. Here totally how many Ag plus ions are there? 2. Therefore 1 into 2 is again 2 electrons. You can select any reaction. Right? By that you can easily calculate the number of electrons. How many electrons are involved in the reaction? 2 electrons. It is also I am writing here only. N is equal to 2. N is equal to 2 electrons are involved in the reaction. Now substitute the values. Substitute all the values in the formula. You will get E cell is equal to, what is the value of E naught cell? Here E naught cell is equal to how much? 3.17 volt. The unit for the electrode potential is volt. 3.17. 3.17. Next, minus as it is 0.0591 divided by, what is the value of n? N is equal to how much? 2 is there. 2 log of the element which is undergoing into oxidation. Which element is undergoing into oxidation? Mg is converted into Mg plus 2. Plus 2 means loss of electron. Mg into Mg plus 2 loss of electron means Mg is undergoing into oxidation. A simple hint is product by reactant. Product concentration is given. Which concentration? Mg plus 2 ion concentration is given. That is 0.3130. Here it is 0.130. And next, power is star. Here star means its coefficient. Here nothing means 1. The coefficient of Mg plus 2 in the chemical reaction is how much? It is 1. Therefore, power is 1. Right. Next, here reduction. Which element is undergoing to reduction? Which metal is undergoing to reduction? Here Ag plus to Ag. Correct? Ag plus is converted into Ag. That is gain of electron. Ag is undergoing to reduction. Just like reduction means reactant. Which is the reactant here? Ag plus. Correct? Therefore, what is the concentration? 0.0001. Here you have to write 0.0001. Now, all the values are substituted correct or wrong? Now also it is wrong because we should have to write this star value. It is very, very important. Star value, that is coefficient of Ag in the reaction. Coefficient of Ag plus in the reaction. How much it is? 2. Therefore, we should have to write here square. That is 2. Now it is 5. Clear? Now, already you know in the first place, if the decimal point is shifted towards the left side, then it will be 10 to the power plus. If you is shifted only one digit, plus 1. If you have shifted 2 digits, it will be 10 to the power plus 2, etc. When the decimal point is shifted towards the right side, it will be 10 to the power minus. 10 to the power minus. If you are shifting for only one digit, it will be 10 to the power minus 1. If you are shifted for 2 digits, it will be 10 to the power minus 2. If you are shifted for 3 digits, it will be 10 to the power minus 3. Here, I want to write it as 1 into. Therefore, this decimal is shifted towards the right side. Towards the right side. How many digits? 1, 2, 3. Right? I want to write 0.001 as 1. Means how many digits decimal should be shifted towards the right side? 1, 2, 3, 4. Therefore, it will be 10 to the power minus 4. 10 to the power minus 4. Now it will become. E is equal to 3.17 minus, here it is, if you divide this value, we will get 0.0295 into log of 0.130 divided by, I am writing this one as 1 into 10 to the power minus 4 because I have shifted decimal towards the right side for 4 digits, square as it is. Now, it will be E cell is equal to 3.17 minus 0.0295 log of this value as it is said. It will be 0.130. Now, what happens here? 10 to the power minus 4 is there. Square means just you should have to multiply these two. It will become 10 to the power minus 8. Therefore, it will be divided by 10 to the power minus 8. Right? Now, next step, what I am doing is I am taking this denominator to the numerator. This minus 8 will become the plus 8. This is equal to 3.17 minus 0.0295 log of 0.130 into, just use the formula. You can use log m by n. Log m divided by n. That is log m minus n. Log m minus n. That's what I am using here. Therefore, it will become log m minus log n. Log n is 10 to the power 8. Here, I am taking this one as m and this value is n. It is in the form of log m divided by n. M by n. What is the formula? Log m by n. Log m minus log n. That only I wrote. Next, here it will be 3.17 minus 0.0295 log of how much it is 0.130 minus here which is log 10 to the power minus 8. Which form it is? 10m is there, theta n is minus 8 means m to the power n. M is 10, n is minus 8. Theta which formula it is? Log m to the power n. M to the power n. What is the formula? N log m. N log m. Therefore it will be here it is n log m log 10. Now just simplify this one. It will be 3.17 minus 0.0295. Here it will be log 0.130 as it is minus into minus plus 8 log 10 is 1. Log 10 value is 1. Right? In log book you will get 000, but here decimal is after 2 digits. Before decimal 2 digits are there, x minus 1. Right? 2 minus 1, therefore it will be 1. Now here 0.130 is there. You cannot calculate directly this value, right? Therefore you should have to shift the decimal towards the right side, just make it as 13 point. Therefore it will be 3.17 minus 0.0295. Here it will be log of, I want to write it as 13 into, I shifted 2 digits, it will be 10 to the power minus 2 plus 8 as it is. Next 3.17 minus 0.0295, directly I am writing here log of 13 plus log, m into n is there, log 10 to the power minus 2 is there, 10 to the power minus 2, that is log m to the power n. Therefore it will become n log n, that is minus 2 log 10. Log 10 will be 1, therefore it will be plus 8. Now just check the value of log 13. What is the value of log 13? Now here I am writing minus 2 plus 8, it will be plus 6. Now what is the value of log 13? 1.1139. It will be 1.1139. Now just calculate this one. How much it is? 3.17 minus 0.0295. It will be 7.1139. After simplification, what is the answer is? The answer for this one is you will get 2.96. It will be 2.96 volt is the value of this one is cell for this chemical reaction. It is how much? 2.96. Clear? Now we will see second problem. Second one. First one what? Second one. Very important for 3 marks, these problems. Second problem. Calculate the EMF of the cell. Now we will take next another one. Calculate the equilibrium constant. Calculate the equilibrium constant. Equilibrium constant, that is Kc, of the reaction. Equilibrium constant of the reaction. The reaction is Ca. copper solid 2 plus raised to Cu plus 2 plus 2Ag. Here given again he is given A naught of cell is equal to 0.46 volt. 0.46 volt. Here, what he is asking, calculate the equilibrium constant, that is Kc, of the given reaction. What is the reaction? Cu plus 2Ag plus U raised to Cu plus 2 plus 2Ag. This one is the given reaction, and he is giving E naught cell value directly, that is 0.46 volt. Now, solution. Already you know formula. If E naught cell is given and he is asking equilibrium constant, one formula is there. What is the formula? That is E naught of cell is equal to, we know that 0.0591 by n log of Kc. This formula you should have used here. Now, what is the value of n? Given data. Given. What are the given things? E naught value directly it is given. E naught of cell is equal to 0.46 volt. Here it is. E naught of cell is equal to 0.46 volt. Next, n value. How to calculate n value? Take anyone. Cu2, Cu plus 2 or 2Ag plus 2, 2Ag. Anyone. I am taking Cu first. Cu2, Cu plus 2. Cu2, Cu plus 2. Here oxidation number is 0. Here oxidation number is plus 2. Therefore, how many electrons are 2? 2 electrons. Therefore, how many electrons are involved in the reaction? 2. Therefore, n is equal to 2. N is equal to 2, and he is asking Kc is equal to how much? Now we will see. Put the values. It will be E naught of cell, how much it is? 0.46. 0.46 volt is equal to here same 0.0591 as it is divided by n. And value is how much here? 2. Log of Kc is not given, then only we have to calculate Kc is equal to how much? Now just try to solve this one. 0.46 as it is here. This value divided by 2, that is 0.0295 log Kc. Next, it will become, if you take this one this side, it will be 0.46 divided by 0.0295 is equal to log Kc. Divide these two values. What do you get? 0.46 divided by 0.0295. It will be 15.59. It will be 15.59 is equal to log Kc. Now, if you take log this side, it will become anti-log. That is, Kc is equal to anti-log of 15.59. I am writing directly 15.6. Now, how to see the anti-log? It is different for the positive values and negative values. How to see the anti-log is, if you want to check the anti-log value, it is different procedure for the negative values. Anti-log of negative value is different, anti-log of positive value is different. Here it is positive value, therefore I am telling directly for positive value only. Here, before decimal, how much is that? 15. Before decimal, what is the value? 15. That will be 10 to the power 15. That will convert into 10 to the power. Before decimal, what is the value is there for anti-log? If the value is positive, that value converts to the 10 to the power. 10 to the power. Correct? For positive value. Before decimal, what is the value? 15. That will convert to the 10 to the power. That is 10 to the power 15. 10 to the power 15. After this one, after 15, removing the 15, what is left? 0.6. That you have to check in the anti-log. Where is 0.6? You should have to search. You will get value, right? That is Kc is equal to, that value is 1. That value I am writing directly. 3.92. The value is 3.92. This one is the Kc value. Next, we will solve another problem. Third one. Third one. Third one is calculate the EMF. We will take another one, that is calculate the potential of hydrogen. Third one. I am taking different types of problems. Third one is another type, that is calculate the potential of hydrogen. Potential of hydrogen electrode. Potential of hydrogen electrode in contact with a solution whose pH is 10. Whose pH is 10. What is the question? First understand. Calculate the potential of hydrogen. Calculate the potential of hydrogen. That is electrode potential only. E cell for the hydrogen electrode. E cell value. He is asking for which electrode? Hydrogen electrode. But we know that for hydrogen electrode, E cell value is 0 only. Either it may be cathode or anode. But that is standard hydrogen. Correct? Standard hydrogen means the concentration of hydrogen ions in the beaker should be 1. Then only it will be 0. If you are taking concentration of all the ions in the reaction, then E naught of cell it will become, that will be equal to 0 for hydrogen electrode. Means E naught cell value is 0 only for the standard conditions. Standard conditions when the concentration of all the ions which are produced in the solution is 1, then only it is applicable. But here he says that it is not equal to 1. Concentration is not giving equal to 1. Correct? Just he is asking calculate E cell value for the hydrogen electrode which is in contact with the solution whose pH is 10. Means, for example, this one is the solution. So their pH is given already. How much it is 10? pH of the solution is given. pH is equal to 10, but he is not giving the concentration of the solution. Correct? pH is equal to 10 is there. Here hydrogen electrode is there. Platinum coil is there. And this one is the glass tube here. Inlet hydrogen gas. This one is platinum. This one is platinum foil, etc. Correct? Now he is asking for this one. If the solution pH is equal to 10, what is the E cell value? E cell value. For that, we need some basic information about the standard hydrogen electrode. Right? We see that one. No. Just remember standard hydrogen electrode. Here, reduction potential we want. Always we are going to calculate the reduction potential. Means for standard hydrogen electrode, you should have to take a reduction reaction. What is the reduction reaction? H plus plus 1 electron gives rise to half H2. Right? I don't want to write half, therefore I am taking here 2. 2H plus will take 2 electrons, then it will be H2. 2 H plus ions in the solution. After giving the 2 electrons, it will convert into H2 gas. H2 gas. This one is the reaction for the hydrogen electrode. Clear? And another basic already we have studied in the first PCQM chapter. pH is equal to minus log of concentration of H plus ions. POH is equal to minus log of concentration of OH minus ions in the solution, etc. And we want pH. If the pH is equal to what is the formula? Minus log of H plus concentration of H plus ions. These two information is enough for calculating the E cell of the hydrogen electrode which is in contact with the solution whose pH is 10. These two basic information is enough. Now we will say solution. What he is asking, E cell is equal to how much? Correct. What he is given pH of the solution, that is equal to 10. Now we will see. We know that for standard hydrogen electrode, what is the reaction? Reduction reaction is 2H plus 2 electrons gives rise to hydrogen gas. Right? This one is aqueous. Here it is gas. Right? Now already we know that again pH is equal to minus logarithm of hydrogen ion concentration minus log H plus. Next, for this one, right? This one is single electron. This one is single electron, correct? Because only standard hydrogen electrode is there, right? There is no other metal is there, only hydrogen. Therefore, single electrode. What is the formula for the single electrode substitution formula? That is E of H plus by H2. Correct? Hydrogen ions are converted into H2, H plus by H2. Right? That is reduction equal to E naught of H plus by H2, that is reduction potential, standard reduction potential for the hydrogen electrode. This one is standard reduction potential for the hydrogen electrode, minus 0.0591 by N log of 1 by H plus ion is there. In place of N plus, right, I am taking here H plus, here I have to write the power, right, star. So this one is the formula, right? What is the power here? What is the coefficient of H plus ions in the reaction? Here H plus ion is there. What is the coefficient? 2. Therefore, it will be 2. It will be 2. In place of M plus N, I am writing H plus. H plus. Just remember, this one is the difference only. And this is the formula for calculating the E cell for standard hydrogen electrode or hydrogen electrode. Next. Just see the values. How many electrons are involving in the reaction? Already is given directly. Data how many? 2 electrons. By seeing the reaction directly, we can say how many electrons are involving? 2 electrons. Therefore, N value is equal to how much? 2. Right? Now, then it will become E of H plus by H2 is equal to standard hydrogen reduction potential. Standard hydrogen electrode. What is the E naught value? It is 0. It may be cathode or anode. We see standard means 0. Correct? It is assumed to be 0 minus for SH3 E naught cell value is equal to 0. Therefore, it will be 0 minus. What is the here? 0.0591. How many electrons are involved in the reaction? Here directly is given 2 electrons. Therefore, divided by 2. N is number of electrons. That is 2. Log 1 by H plus by minus, correct? 1 by H plus 2 to the power 2. I want to write this one as here H plus is in the denominator. This H plus ion concentration is in the denominator. I want to take this one as numerator. Therefore, what happens? This H plus to the power minus 2. It will become minus 2. Therefore, it will be concentration of H plus to the power minus 2. Now, just observe. It is in which form? Log m to the power n. M is H plus, N is minus 2. Means what is the formula? N log m. Correct? N log m. Now it will be E of H plus by H2 is equal to 0 minus 6 directly minus 0.0591 by 2. Which is the form of log m to the power n. Therefore, it will be N log m. N log m. Now this what happens? Here 2. It cancels. Correct? 2. Now, what is left here? 0. Minus 0.0591. Here it is minus log of H plus. Minus log H plus. Correct? Now, here it will be 0.0591. Minus log H plus means it will be pH. Correct? Now, this value is equal to pH into pH. Now, it will be minus 0.0591. pH value already is given. What is the pH of the solution which is given? That is 10. In place of pH, just write 10 into 10. Therefore, it will be minus 0.591 into 10 means it will become 0.0 converted into 0.591 directly. Correct? Volts. This much of volt. Here I will start because this formula is very important for solving the NEET or JW questions for hydrogen electrode. Only for the hydrogen electrode. Sometimes he will give the pH and he is asking E of hydrogen electrode. Correct? E of hydrogen electrode. Then we can use this formula. No need to do all the things, right? Just remember this formula for hydrogen electrode. What is the formula? E of H plus by H2 is equal to minus 0.0591 into pH. It is very important while solving the NEET or JW questions. Just remember this one is very important.